Good morning and welcome to the 41st Annual Winter Star Party.
Hi, I'm John Talbot, and today we're going to talk a little bit about Pixinsight and some of the favorite scripts that I like to use when I process my images, and a little bit about the new program, the new version of Pixinsight itself, and some of its great new features. What this presentation is going to sort of be about, kind of a demonstration presentation of kind of what I use when I process images with Pixinsight. I mean, there are so many things out there. It's a very, how many in here use it? Yeah, so pretty much everybody. So, it's a complicated program, right? I mean, there's lots of scripts, there's lots of things that you can get. People develop their own because it's sort of open source. So, there's a kind of a set of ones that, I typically mess with. And so I'm going to go over those, and I'm going to kind of tag team between a presentation, and it's going to be in this mode because I can't go to presentation mode and then bring Pixinsight back up very easily. So, but I've got a bunch of links on here, the slides, and I'm sure after this is over, you'll be able to either take a picture of the screen with the links. It's just how to get these scripts. You may have some of them already. I don't know. But I've been dealing with Pixinsight since it came out in probably 2006, I think. And it's evolved up to the point where we had this new version that just came out a couple weeks ago called Lockhart. And it has some interesting features to it. So I thought I'd show at least one of those features, which is this what's called multi-scale gradient correction. And it uses real data from the sky taken with really wide field systems, like 35 millimeter wide field systems, and you're trying to match that up with your image, which may be taken through a 1,000 millimeter telescope, but it's real data, and the gradients are such that there could be gradients actually even in this data they take from Spain. However, they're not going to be complicated stuff like maybe you have at home. Maybe you got a light dome over here, light dome over here, something over here. So those are all small scale things which this weeds out. And so we're going to talk a little bit about that, kind of show a demonstration of it, how you get it running, how you set it up, how you do it. And then some of the scripts that I use, and then we'll go from there. So I will mention one thing. This version of Pixinsight is terrible with a Mac. I use a Mac. If you use a Mac, I would hold off in updating. Some of them work, some of them don't. Mine, I had problems with things crashing on me, and I got a hold of the developers, and they sent me a beta version that they're working on, and it fixed some things for me. But if it crashes, it's going to crash, and I'm going to have to restart it. So I can only have one version loaded on a Mac. I can't have both. Maybe like on a Windows machine you could. So I can't just go back to like the older version. The older version, Ripley 1.89 version, whatever. I think it came out in October. That was as stable as I ever saw. That was really good. It works really good, at least on my Intel-based Mac. The new version, if you may have an M1 or an M2 chip, maybe it works just fine for you. I posted an image on their forum. I said, "Hey, can anybody get this thing to work?" I was going to run Star Exterminator on it, and every time I did it, it crashed, just every single time. And I don't know. I created the image using the new version of Pixinsight, but it just will not work. And I had people say, "Oh, I'm using this Mac and it works fine." So just a heads up, if you use a Mac, you may want to hold off for a while in upgrading. Personally, I'm probably going to go back a version, to do most of my day-to-day drudgery work because there's just some issues that I just never know when it's going to come up. But hopefully it'll all work here. I hear it works fine on Windows machines. And if you use Linux, which is another option, it tends to work pretty good on a Linux machine. And of course, the developers have no issues on any of their development machines. It works just fine. Well, they prefer Linux, yes. That's the preferred solution, that it runs the most efficient and fastest. So we're, it's got some issues right now, but I think we'll get through what I want to show, and yeah, that'll be good. And hopefully in a couple, a month or two, they'll come up with a fix for it. I don't know I have no clue what the issue is internally, but apparently maybe their development machines are not like a typical person would have, mail on their machine, different programs, all kinds of stuff that you would use, right? Theirs are probably sanitized. That's all they got. So anyways, so we'll go from there. So the latest version is 1.92. Lockhart, it's called. That's the key name for it. It was released in December, right around Christmas, so it was a Christmas present for everybody. It had one really big change, and that is this function called multi-scale gradient correction. Do people in here use DBE? Yeah, and hopefully I'm going to show you kind of how I do DBE, which may be different than the way you've seen it done before, but I showed this out in Okitex last year. And then I'm going to compare this version, multi-scale gradient correction, with an image that I did DBE on. So it has this, you can see the interface there. There's a couple steps you have to go through to get it up and running. But it seems to work pretty good from what I've seen. If you think it's simpler, forget it. If you think it's just the all one button push and that's not the way this program works. There's always some tweaking you may have to do. And they have some really great videos out there on their YouTube channel that go through this. And they tell you the different ways to adjust things if you see problems. So I would recommend you look at their YouTube channel. They've got some really good stuff. And then of course there's all the other YouTube creators that that are putting that stuff out as fast as they can. So they have some good things, but just try not to believe everything you see there. Everything, just because somebody says it works great or it doesn't work great, doesn't necessarily mean it's one way or the other. So. All right, so multi-scale gradient correction uses this thing called the Mars database. This is a database where they have an observatory set up in southern Spain, and its whole goal is to shoot the entire northern hemisphere sky in wide field, right? They're going to shoot it in RGB, and they're going to shoot it in H alpha and O3. And maybe eventually they'll do it in the other popular narrowband S2. But right now, it's not quite finished, but there are areas of the sky, generally the summer Milky Way. And the summer Milky Way is pretty well covered. They have some H alpha data there that I've tried, and it works okay. So there's actually even some early winter stuff that, but they show a nice graphic, and this is the kind of the area of the sky that's currently covered by broadband, our RGB, goes from about Perseus maybe here around almost Budas. So, and areas that are more white, there's actually a lot more data there. But it's a multi-year project, and probably this time next year they'll have the entire northern hemisphere done. In the meantime, if you're trying to use this on an image that's not covered, you can't. You have to go back to DBE, so you need to know that. So, and then this is the HA side over here. So they have quite a, I ended up having a couple images that were I took last summer that fit in that HA area. So it worked pretty good. So that's the Mars database. You can go on the forum, on the Pixinsight forum, and there's a whole section about how this whole thing works. And you can see these graphics on their website and stuff like that. So another cool thing this new software does is image synchronization. What that means is you may have two images on your screen, and you put your cursor on something. Maybe you're looking at a galaxy and the image is plate solved, right? And you can see, you know, the RA and deck coordinates. If you, depending upon your machine, if you sync those images together, whatever you point to on this image points to on the other image. So you can compare, like you have an RGB, you have an H-alpha image, maybe that has some cool stuff in it. You can put your mouse around that RGB image and see where the corresponding spot is on the H-alpha image. You know, it's a neat feature. Do you need it? Probably not, but it's kind of cool. So that's the other kind of the other sort of big thing, I guess, would be image synchronization. So, all right. So what I'm going to try to do here, see if this works. I'm going to pull up an image, and it's an RGB image I took with a color camera, and I took it in last summer in my backyard. You know, I live in a Bortle 5, maybe sometimes 6, depending upon humidity and whatever. It's definitely suburbia. It's not, you know, dark, and we'll run that image through the multi-scale gradient correction. So, oh, wrong one. Sorry. So it's the Cocoon Nebula. Everybody's familiar with the Cocoon Nebula. So when I mentioned I took this with a color camera, why does that come up like that? That throws people for a loop half the time when you open it. Because you got double the green pixels on a Bayer matrix camera, right? It's a lot more sensitive in the green, and it's actually the quantum efficiency is the most sensitive in the green. So it's always going to have a green tint to it for the most part. A mono camera doesn't necessarily suffer from this, so it's easily fixable. There's this function called the screen transfer function, which allows you to show the different channels in different ways, and it'll automatically adjust them for you. But you have to turn off this little, you know, the little lock button which links your channels, which is right here. And then it looks okay. So let me see, let me turn that off, and I'm gonna kind of redo a screen stretch, and it kind of looks like a normal image now. And hopefully you can see that, yeah. So, so the Cocoon Nebula, this actually has a gradient from where I live that is brighter. This is a high dynamic range screen, and it hasn't been adjusted, so it's hard to see the gradient, but it's there, believe me. It's up here, and it's darker down here. So the first thing you have to do is you have to plate solve when you're going to use multi-scale gradient correction, right? So, and there's a new version of plate solving which didn't necessarily work on my machine, but with this beta version it does work. So and they've changed where it is. So you go to Scripts, Astrometry, and up there. Astrometry and Image Solver is up here now. So it's in a different spot than the old version of Pixinsight. So you pull that up, and I'm not really going to, get into the details of, the star catalogs. You may have the star catalogs on your computer already loaded. It'll go out on the internet, also, right? To get those. In my case, I have them actually on the computer, so it pulls up the FITS header of where this image was taken, and RA and DEC, and the date. You can see it was taken in August, on August 8th. And pixel size and my focal length, I just use a little 80mm refractor. So So if you try this and it does not work on your machine, it's probably going to be a Mac, it's probably this, distortion correction. It would not work for me, just would not work, because they changed the way they do that now. They changed the way that they create these things called splines and how many points go over the image. And because of that, it messed something up. Now it works. At least the beta version I have works. So they'll probably be coming out with the latest and greatest. So I'm just going to hit go, and it's going to figure it out, hopefully here in a second. It'll find the stars in the image, and then it'll compare them to the database and go from there. 77,000 stars, a lot of stars in that part of the, I mean, that's like dense. Oh, so it looks like it's actually downloading the data. Yeah, okay. I probably didn't change it. Yeah, so I'm running this thing through my phone as a hotspot, and looks like it's getting it. So my resolution was around 1.6 arc seconds per pixel. This was a ASI 2600 MC Pro camera, Bayer matrix camera, which is pretty darn sensitive. All right, so it seems like it's figured it out. Once it gets to that point, you know you're good. So it's figured out where it is in the sky, the focal length, how the image is rotated, and all that good stuff. And you need to do that first. That's number one. Okay, number two is there's a brand new process, and it's called spectrophotometric flux calibration. Okay. And this process has to be run second. So what it does is it goes out to the Gaia database and it figures out how much different your image is from the image that's in the Mars database when it comes to flux, which is the brightness of the stars. It has to calibrate your image to what's in the database, and this is how it does it. So in this case, if you're using a color camera, you pick ideal QE curve up there. If you're using a mono camera, it's different. You can actually pick, like, this is the one the cameras I normally have, these Sony sensors. So I have a 6200 camera, which is a IMX 533 or 460 533. So a mono camera is a little different, but a color camera, you just stick with the ideal QE curve right there. And I know a lot of people use color cameras. The gray filter, well, you don't have to really worry about that if this is a color image, because this is RGB. What would happen here, or the reason you would use the gray filter, say you have an HA image, right? Say you used your favorite HA image. And what you're trying to do is work on the HA image to get rid of the gradient. You would go down here and you could pick your filter, and there's a whole bunch of them in there. But it's going to automatically not even worry about that because it knows this is an RGB image, right? So that's a little, that's something you have to think about. If you pull up a black and white image, you got to put your filter in there. And then in my case, on my red, green, and blue filters, I have the Sony color sensor, and they're the typical UV IR cut. That's what's on that chip, So it actually defaults to that. So if you're using like a 2600 camera, 6200 camera, any one of those IMX type sensors, whether it's ZWO or maybe QHY, and it's a color camera, that's probably the default that you're going to pick. All right. So once you have your stuff in there, it's going to use this database, this Gaia DR3 SP, which has color information in that database. The Gaia satellite has looked at all these millions of stars and figured out what color they're supposed to be. And it's all gone into the database. So you hit go down here. Uh-oh. No database. Let me do something here real quick. I forgot to set up Gaia. I literally installed this before I left the house, and so let me put my filter, my database in here. WSP. Select. It's probably here. Catalog. No, it's probably not it. Yeah. It should be it. All right, let's see what it says now when I run it. Okay, so here we go. Hey, you can guess, at home I was frustrated that things weren't working, and then he sends me this brand new beta version like the day before I drive. And so it's going to do a normal thing where it's going to fit the stars to the image. You've already plate solved it. It knows what it's looking for. All right, so it's going to come up with this curve when it's done. It looks like there's two little wings on each side. That's typical of what you're going to see, no matter what filters you're using. These wings are where stars are not fitted for whatever reason. And this area in here is where the stars are being kind of adjusted and calibrated to the Mars database. So that's the typical look of it there. And that's what you will see with, if you have an H alpha image, it'll just be a single, you won't have three different colors, you'll just have a single line like that. But that's the normal look to it. All right, once that's done, you're at the point in life where now you can run this new thing called multi-scale gradient correction. So under processes, all processes here. Yep. This is what you'll probably see when you first open it. I haven't, again, I've got to load the databases because this is a new version, so I got to go find them. You download these from, the Pixinsight site, and I got to go find the, let's see here. Let me find, where's my Mars? There. Here it is, right here. So these two files, they have this extension to them, .xmars. And those are the two files that are available right now on that Mars database that covers that portion of the sky that I showed. So you only have to do this loading of them once, and they're in the system. So here we go. I tell it which ones they are. Yes, those are the files. And it gives you options down here. Gray filter, red filter, green filter, blue filter. That's just, again, those are, it knows this is an RGB image. I don't have to change a thing. I don't have to put any, maybe my gray filter, maybe I've got an H alpha image. Well, I need to tell it that this is an H alpha image, and I would select H alpha if it's a mono image, right? So again, you select the ones that you have, and in this case, this is an RGB image, so there's just RGB. It has a couple other settings that I would kind of leave you to watching their video on their YouTube channel on how to adjust this stuff here. It changes depending upon your image, the size. I mean, you know, there's all kinds of different adjustments that you can make if you run into trouble, but that would be a whole, you know, whole nother hour just to go through all that stuff. So the defaults tend to work pretty good for most images, and in this case it does. I have the Mars database up there, and I hit go. And with the defaults, it's gonna figure out, it's got 6 images that it found in the database, in the red, 6 images in the green, and 6 images in the blue. So those are the images that it's going to use to compare against, and these are real sky data, you know. And it's done. So what it came up with, this is the model it came up with, and it's hard to see here, but it's brighter up here and less bright down here. So that's the gradient that it says is in the image, which is pretty close to when I did DBE, you know, pretty close. And whoops. So it corrected this image here with that gradient, and on my screen I can see it easy. It may be tougher to see here. Maybe we can go back. Maybe it'll show a before and after difference. That's before, that's after. Yeah, on that high dynamic range screen it may be tough to see, but it basically flattened the whole image out. So that is the cool thing with, you know, Pixinsight. So what if I had a different image? I'm going to attempt something here. I'm going to pull up this HA image. I think yeah, this is one with no stars. That's not what I want. Okay, so here is one that I took this summer. This is kind of, excuse me, flipped upside down the way you normally see it, but that's the wizard, right? And there is an actual supernova remnant that is here. You can kind of see some of the pieces of it. It's kind of curved like this. And I shot that for a professional astronomer up in up in New Hampshire. I think at Dartmouth. So it's a basic just HA image, right? Well, what if I wanted to run gradient correction on this? So first thing I got to do is I got to plate solve it. So I got to go here, here, image solver. Came up with the coordinates. So this is a different scope. This is my bigger refractor. This is 1200 millimeter focal length. let's see what happens here. I'm gonna let it run. So this is like a 120 mega, this is a 9,000 pixel by 6,000 pixel image. It's huge. It may take it a minute to do this. But I'll show you kind of the differences when you want to use a, you want to use an H alpha, how you change that gray filter in there. Let's pray it doesn't crash it. It really makes your life easy if you're in a place you don't have internet to have those star catalogs loaded on your computer. It's gigabytes worth of data, but you don't need any internet connection. It just does it really quick. Okay, so looks like it's doing it. I'm curious to see if it worked, good. So twice good for this beta version of software. All right, so that's the first one. So the next one I need to run is what? Flux. The Flux. So here I go to spectrometric flux calibration. Now this is a mono camera. This is different. So this one, the QE curve of this camera, this is a IMX 455 camera. It's a full frame sensor. My gray filter in this case is a Chroma 5 nanometer HA filter. Let's see, maybe I just, no. Let's see here. Where are you? It's got chroma, red, green, and blue. Interesting. Oh, sorry. Yeah. You have to click narrowband filters mode. There's a little button up there at the top, and you have to click here. So what you do is you put in, so this is going to be HA, and the bandwidth was 5 nanometers. So you put in 5 nanometers up here. You may have a 3 nanometer filter. You may have whatever yours is. That's what you put up in there. All right. That's for the gray filter because it's a grayscale image. So that, and I run it. So it knows what the QE of my camera sensor is. And if you haven't looked at them, it's kind of interesting to pull your sensor up and look at the QE that they have built into the program. Some of them are pretty darn high these days. Okay, so there it is. Same type of look to it. It's got these two tails. This is the data where it's going to use that to calibrate your HA image to the HA image that is in the database. All right, so that's number 2. And then, did that. And then what I do is I run the multi-scale gradient correction. All right. So my gray filter here, I put HA because that's what I'm interested in. I want to know what the HA data is in the Mars database. I want that data. So it's HA. You don't have to worry about your filter. You just have to know the band. So that, and I hit go. And it's going to go out there and look and see what's in the database. Oh, it's got there's 5 images in the database in HA. for that region of sky around the Wizard Nebula. And this is what the gradient came up with. What do you notice? Yeah, so one button push, not all the time. And on this particular, on the color images, I found it works really good. But if you have a big thing in your image, now you got to go back and adjust these things, right? And what I found, and it's trial and error. I mean, it's you know, if you see something like this, you know you're subtracting your nebula out of the image. That's not what you want. So for this one, I believe I had to go change the gradient scale. Let me hear. I mean, if you really look at the image, the before and after, it didn't change it drastically, but it definitely made some areas here darker. So to fix that, what I had to do, I'm almost positive, I had to play a little bit, and they explain these different scales and what they mean. I had to go down, I believe, let me try 512. I'm going to show the gradient model because I want to see what it looks like. And I changed this thing called structure separation. It kind of, if you have a, you know, maybe you have a fat galaxy here, right, in the image. Well, in order to separate that galaxy from the rest of the sky, you need to change this structure separation function. And then you need to run it, and you need to see what it looks like, and maybe you need to adjust it again. So if you thought it was the best, great, all one button push, it's not. So I'm going to run this one, and I'm going to see, I think this is what I had to do. All right. Nope, I went the wrong way. Okay, I'm going to keep that one here. And I'm going to go to 2048. It got brighter, so I went the wrong direction on the gradient scale. What that gradient scale is you know, you can't totally match the images, your image with the database. So it's a way that it it changes the how much, I guess, how much factor it puts into the image and how much it subtracts. So let's look at this one. Okay, so that's better. So here is before. Here's the first one. Really bright. You can actually see the outline of the nebula. You can see how it's a curve, you know, it's the Wizard. And here it is now. It's more of a, and there is a general gradient up in this part of the image. It just happens that that's the way it is. I just didn't want to have to get rid of the actual Wizard. I didn't want to get rid of any of that. So I'm going to pop this up one more to 3072. And, whoops, sorry. Need to back up here. All right, run it. All right. So now we have something like that, which was most correct. Because what I did is I actually took the image, I made a copy of it, I got rid of the stars, and I ran DBE on just the image, and I ended up with this gradient in this corner of the image. So that's kind of what I ended up having to do to make it match what I could do in DBE. So that's why I tell you, I would mention, watch their videos where they talk about how to adjust this gradient scale and the structure separation and the scale factors. They do a pretty good job with it. So, all right, so that's multi-scale gradient correction. And anybody have any questions about that before I move on to a different thing? Has anybody tried it in here and been successful with it? Yeah? So I find it works pretty good on RGB images, but then again, you know, it may depend on the area of the sky you're shooting and how complicated your gradients are. So, so if I took this image, let me show you how I do gradient correct, how I do DBE. If I was going to compare something, right? So let me close some things here, get rid of that. And let's pray for a non-crash. So what I want to do is, the way I do DBE, especially in dense star fields, I get rid of the stars first. And it works perfect every single time. So I would go to Process, Star Exterminator, and you may have the other star removal algorithm on your machine. There we go. And let's see if this, okay, I'm just selecting, I want it to generate a star image, and it's going to take a bit to do this because this is a big image. It seems to be going all right. If you don't know, if you use a Mac, it's automatic star exterm. All the exterminators are accelerated on the Macs because the guy that made them, he uses Macs. So he kind of somehow tweaked them, and they run quite a bit. They run pretty darn quick. And this is not a new machine. This is a 2019 machine. So. All right, so I have this starless image now over here, and yeah, see the supernova remnant? Did you know there was one there? It's there. I don't know when the star exploded, but there is no other side to it. It's just on this side, and it's got O3, it's got S2, it's got the whole thing. But so for me to run DBE, that's the first thing I do. Then I open up DBE, and I place my samples on the image. And I place them in air, you know, I try to figure out where is there relatively very little signal. Well, there's very little signal down here, up in there. There's a darker area here that, you know, the image being upside down, but that's kind of looking down towards my eastern sky here with the way the telescope is set up. So that's, you know, I have a big a lot of light pollution there. So I would put some samples in here like this. You don't need that many, but you want to make them big. Over here in the dynamic background extraction settings, tolerance you put at 10. You max it out because you have no stars. And your smoothing factor, this can change based on gradients. I find 0.6 works pretty good, 0.65. If you have very complicated gradients at home, a lower number would be what you want. And then for the sample generation, these are big samples. So maybe I could put something like 40 pixels, I don't know, big ones. And I'm going to go around here and I'm going to place some, I'm going to look for areas that are relatively the same brightness, you know, something around right there. Over here. And I definitely don't want them on bright objects, that's for sure. Right there. Maybe something like that. All right. You don't need loads of them. I mean, maybe a half a dozen or a dozen. Can you imagine doing this in a Milky Way field with all the thousands, like that image of the cocoon? You have to get rid of the stars before you can do it DBE effectively. So let's see what it comes up with. All right, so this is the background that it came up with. Let me get this guy to move here. All right, so can you see how much brighter it is over here? That's very similar to what I got with multi-scale gradient correction after I had to adjust things, right? So it validated my idea of what I did, that it worked right. But to be honest with you, if you do DBE this way, maybe you never even have to use multi-scale gradient correction because it works really well. So after I'm done with this, right, what I do, here's the key to what's at the bottom here. The key is, for correction, you want to use subtraction. You want to normalize the image. What that does is, it's going to subtract data out of the image. You want to put the values back to what they were originally after it takes the gradient out of it. And I'm going to replace the target image. All right, so there we go. Okay, so that's my background. I didn't have to show the background again, but that's just the same thing you just saw. This is the corrected image. And if I get rid of this, so that's, we'll go before and after. You can see a little bit of change in this area. So now I can move on to whatever processing I want to do, but maybe I want to put the stars back in the image, right, before I go anywhere else. Well, who knows how to put the stars back in the image? This is this really weird function called pixel math that people freak out about. But it's really simple to use. So I've got two images here. I've got one that's called image 5 stars, and then one that I have called image 5, which is the one I just did that gradient correction to, right? So I just pull up, take pixel math, find it. And there's two ways I can put those in there. All I need to do is add them together. So if I go here, this expression editor, it lists my images. So image 5 and image 5 stars were those two images. So I just say image 5 plus image 5 stars. It's that simple. And you have to, you may have to check down here to see whether you have replace target image or create new image selected. It defaults to replace. So that's typically what it has in there. And I just drag the triangle, or I hit go, and it puts the stars back in. Boom. Just like they've always been there. So if you haven't tried doing DBE this way, try it. Works just as well on an RGB image, whether it doesn't matter what it is. You get rid of all your stars first, pick similar areas of similar brightness around your image, run it with that normalized selected, and you'll end up with, I think, some pretty cool results that'll be pretty awesome. All right. So, okay, let me oh, there is another cool thing with this new version of Pixinsight. There's a thing called fast drizzle. It probably runs 50% faster than the original drizzle algorithm. Who in here uses a color camera? And I assume the rest of you are mono. Okay. You should always drizzle your images. Always. Whether you're using a color camera or a mono camera. You don't have to drizzle them up in size, but you should at least use 1 times drizzle. It makes a huge difference in your star profiles. And of course, you can select that right in WBPP, right? Where you put all your frames, and you put your dark frames, your flats, and one of the options is you can select drizzle. And I would just select 1 times drizzle, so it doesn't change the size of your image unless you're undersampled and you want a bigger image. But drizzle is important, and it really makes a big difference with Bayer matrix cameras. It changes the color balance for the better. If you don't use it, your color balance isn't necessarily right. But they've come up with this new algorithm that is really fast. I mean, when I did it at home, I did it on like 30-something images. And probably did it. I mean, it was like, whoop, one, next one. I mean, like 5 minutes. And it was versus, what, an hour in the past? So it's a really good algorithm, and it seems to work really well. At least it worked okay for me. So these are some of the scripts that I typically use. And I have these in my repository. There's a whole bunch of them here. And I think I am connected. So let's see if this is going to work.
Can you go back one slide?
I will, yeah. Yeah, maybe my phone, yeah, I'm connected. Okay, there we go. So if you go to the web page, I put all the links for these scripts. Like here's the cosmic photon stuff. This guy has some really good scripts that work really, really well. I just have all of them, but color mask is one. It allows you to target different funky colors maybe in your image and change them because they're not right. Something, maybe you have a extra gradient or something in there. It's a really cool script. He has this solar toolbox, which if you're a solar imager, it makes life easier for you on processing those types of image. Image blend is it's one of the coolest scripts out there. It basically takes all the functions, if you grew up with Photoshop and how you blended images together with Photoshop, it's the same math, but it's in a script format, and all you have to do is you put one image here, and you can change the blend of how they go together, and it does all the same math. So this narrowband color mapper is another one. If you have a raw HA image, maybe an O3 image, and you want to create a HOO type image, you can create any color palette type of thing that you want. Real easy. It is pretty awesome. And then there's another one here called narrowband normalization, which is one that you can use on an image to change the relative contribution of something like hydrogen alpha or O3 in a color combination. It works really, really good. And he has also some star reduction scripts which work really well. A screen star script. He has a draw annotation script where you can, you know, if you've used the annotation function of Pixinsight, you notice that sometimes not all the catalogs are in there. But you may know of an object in there and you want to highlight it. You know, you can draw your own little circle with the stuff on there, and it puts it right on your image. So that's a cool script. There's a way to edit fits files. I've never messed with that one. This is the color mask one. Of course, this is the same folks that came up with GHS, if you're familiar with that. So anyways, that's him there. And somebody wanted that back up. You probably want to take a screenshot of it or something. I think, you know, this is all being recorded, and I think you guys will all be able to, once Sergio gets this all put together, you'll be able to see it and stuff and download it. SETI Astro is another individual that's kind of newcomer to writing scripts, but he has some wonderful stuff. He has a script that goes out and searches databases, and if you want to know what's in your image, it'll find stuff that's you never knew was in there. He's got a couple of really good things. Hartman Borneman, another guy that has some scripts that are used for, like, there's a script called Game. Have you ever heard of Game? It allows you to draw. Maybe you have a galaxy and you need to draw a mask. Well, in Photoshop, it's easy. You draw a mask, right? This allows you to draw right on there and create a mask. Like an oval, like a galaxy mask. And you just output it and there's your mask. Makes mask making simple. He developed that with Adam Block, and they came up with that, that script. SETI Astro has this guy here. Let me he's got a lot of YouTube videos that go with each one of his ones. This this one here, narrowband to RGB star combination, is freaking awesome. Say you're using a dual narrowband filter in your color camera. Well, you're not getting RGB stars, you're getting some funky stars. Well, you can break those stars out and recombine them into what looks like RGB stars with this script of his. It makes a pretty image instead of having funky looking stars. And it's very simple to use. He's got this statistical stretch where it's just a one button push to stretch your image, and it works pretty darn good if you don't like to play with curves and histogram transformations. He's got a script that finds the background in your image, and what that does is it you may have nebulosity in there, you may have other stuff. Well, where's my real background? Well, this script will find where that background is, and he explains how to use it fairly easily. He has an automatic DBE type script that will. I've used it. It works okay. I think I can do better myself with DBE. However, especially the way I showed you by taking the stars out, managing where you put your points, and some of those settings I talked about, I think I can do typically a better job than his script does. But his script shows me where he puts his samples. I can readjust them too, and I can almost come up with the same result. So he's got a YouTube video about that. This mask merge utility is really cool. Maybe you have several galaxies in there, you want to mask them. Well, he's got a script that you can physically just take your mouse and draw a circle around that around the galaxy, and it'll create a mask. Maybe you want, and then you draw it around another one. And then you use this utility to put those two masks together, and now you've got them both on the same image, which you can apply to your image. I mean, it's pretty amazing. He's done a really good job with this stuff. Yeah, that's that's it here. Freehand adaptive mask editor. So this is where you just draw on the image to create a mask. I bet you nobody in here ever had heartburns over making masks in Pixinsight, right? Pain in the butt. Easy way to do it right here. And then his big one is what's in my image. He goes out and it'll search all the different NASA databases, actually the different databases around the world, and you can, it'll identify thousands of things in your object, in your image that you never knew were even there. Maybe you see something that's kind of funky looking, you want to know what it is. Well, use this script. So anyways, so that's, he's got some good stuff. Hartmut-Bornemann stuff is here. That's, and the what I want to show you is this DB extract. Does anybody use that script? Okay, so you have a color camera, Bayer matrix camera, and you have a dual narrowband filter in that camera, Optilong, L-Enhanced or something. I use the Antlia one. All right, so let me pull that up here. I'm going to get rid of this, get rid of that. Yes, close. Go away, go away. So this image, let's see. Huh, okay. So hopefully this will work. Okay. This is an image I shot with my color camera from home, backyard, with a duo narrowband filter, HA03. And you know, it kind of looks like a color image already. The thing is, there's a lot of other light that gets through that filter. These chips are very sensitive. Like in the HA band, you get blue and green light that gets in there. It's very sensitive to that light. So there's a script out there that takes care of that. If you want to pull the HA or the O3 out of the image, it's called DB extract. And it's on that list. So this is the help file, which is really good for it. And it kind of shows you what happens. So here's your H alpha band. Well, look, you got blue and green light that's getting in there on that color chip. In O3, you've got HA light that's getting in there. Not a lot, but some, right? And it adds to your signal. It adds to things that aren't supposed to be there, but are actually there. Because of the quantum efficiency of the chip and how sensitive it is to different colors of light. So he's figured this out, and he actually subtracts this extra funky light that's way down here in places it shouldn't be, and gives you a pure signal image. So here's an image of the Tulip Nebula, and I want to process this like as an HOO image, right? But I need to get rid of that extra light. Well, I need to know what's my camera sensor. In this case, I'm using a 571. That's a 2600 camera. That's the IMX 571. He lists a whole bunch of different sensors, and they're all a little bit different on how sensitive they are. And in this case, this is an HA03 image. So under HA03 filter, I'm going to select this image. I apologize. Keep on coughing or keep on yelling, the more I'm going to irritate my throat, I guess. So I just put the image I want in there, which is the HA03 image, and I select extract. And it's going to do some funky math. And I'm done. So what it gives me is the actual HA image, which is that, and the actual O3 image, which is here. And you can see there's some O3 here. There's actually a little planetary nebula that shows up in here. I was really surprised to see it, a little tiny thing. And then you would go on to other things once you have an image like this, right? So, so does that sort of make sense on what it's doing? It just does math and it gets rid of that extraneous light. So now, what if I wanted to take this image and make a color image out of this, like HOO? I know that throws a lot of people for a loop. How do I take narrowband stuff and put it together? What do you think you'd do first if I had these two images, an HA and an O3 image? Well, that's one thing. Not the first thing I'd do. First thing I would do is I'd get rid of the stars. And I think, let me see, I think this image is the one that kept causing me trouble. So, yeah, okay. So, I've already done the, let me pull up those images. Close that window. All right, so I want to build a nice color image out of this duo narrowband filter that I just shot something in the sky with. So I run that dB extract on the image, get both of those frames, and then I get rid of the stars. And I end up with these two images. That's the HA and the O3. So I got to do something to them. I have to stretch them somehow to make them look nice. That's the kind of the first one of the things you need to do. And the other thing you need to do is you need to do this thing called linear fit. Has anybody heard of linear fit? You want to take that O3 image and you want to brighten that image up to match sort of the HA image. And there's a function called linear fit. That's kind of like once you get rid of the stars, you take care of your gradient. That's the first thing you do. Run linear fit. So I would say, okay, go down to linear fit. There it is right there. My reference image is going to be typically the brighter one, and in this case that would be the HA. So I pick, it'd be number 19. Yep. And number 20 should be the O3. All right. So I'm just going to run linear fit on that image, and it's going to adjust the values in that image to match the HA image. So you're kind of boosting the, because the sensitivities are different, you have to do this on a narrowband image. All right, so here is my O3 image. Here is my HA image. So pretty cool looking stuff. You know, and look at the big thing of O3 here. This here is Cygnus X1. That is the shock wave from the supernova explosion called, you know, from that star. But this is the O3 signal from that. It's a curved, the star is actually right here. It kind of shoots a jet out that way. So I want to show stuff like that. I mean, I want it to look nice. All right, so I've got, I linear fit the images, and maybe I don't want to, you know, spend all day trying to figure out how to stretch them, but I got this cool script here from SETI Astro, like I was showing you, called Statistical stretch right there. And what this does is you tell it what target background you want, and he has some notes in there about things to start with. Usually in an image with a lot of nebulosity, that's a good value to use. 0.25, I guess. And let me see here, image 20, execute. All right, I'm gonna let it run, see what I get. I believe this is the 03 image. All right. Okay, that's my image there. So it has stretched it, and I'm going to run the same thing on this one. I'm going to run SETI Astro, statistical stretch. And believe me, you can play with your own ways of stretching an image, but this is just an easy way just to do it, and it does a good job. Image 19. If you want to show a preview of what it's going to look like, you can click there. It throws a preview in there. Execute. Do the image. All right. There we go. So now I've got two stretched images. One looks like that. One looks like that. How do I put those together color-wise to make them look nice? Well, Pixel math is the answer. If you understand pixel math, sure you can. There is a much easier way to do it. There is from Cosmic Photons, and this is one of my favorite scripts. Let's see here. There it is. It's called Narrowband Color Mapper. So what I do is I load my HA and 03 image into this thing. So I say, okay, let's, I'm going to update, let me put the HA image in there. I think that's number 19. Yeah, I think that was that one. That's my HA image. Now, I put that in there, and now I can make it any color I want. This is kind of the way people used to do it in Photoshop years ago, except this is a nice script that does it for you. You just pick things. So I have a color wheel here. I know HA is about, on the color wheel, it's at 347. And I put the saturation at 1. All right, so here's my HA image. So now I hit update. Now I load my 03 image. I'm going to add an image, and this I believe is number 20. And I can pick a color here. What do I want my 03 to be? Well, a lot of people like it around 180 on the color wheel. I just type like that, or I can drag this little line and I can pull this thing around to that spot. There we go. So now I have this cool color image. You can see the 03 shockwave here out there from Cygnus X1. You can see there's a bunch of other HA and 03 throughout the image. This is a really faint object called STDR, I think 103. It's a possible planetary nebula. It's got HA and 03, kind of an arc there. This is a tiny little planetary nebula itself. That's a reflection nebula up there. But this script offers you an easy way to put together a decent looking color image. And if I like that, you know, I could change the color palette. Maybe I don't want 03 to be kind of like that teal color, which is kind of the real color of 03. Maybe I want a blue. You can just put.
You can add 20% HL, which is the bluish color.
Well, you can, but this gives you a visual feedback to make an image, real easy. Using pixel math the way really frustrates lots of people of what percentages to put in. I mean, people just go crazy when they come to me and say, how do you know what the formulas are? Well, I picked it up from other people and how they've done it, you know, but this makes it, you put your image there, you pick the color, you put how bright, how much saturation you want, and it's a real simple thing. You can, maybe you have S2 also. You can put the third image in here and make that a different hue of red, and it'll show, but it's all direct feedback, and it's just using your mouse, right? So this is a really, really cool script that was made just for this type of stuff. Once you're happy with what you got, maybe, you know, it'll automatically neutralize the background. Maybe the background, you don't like it, it's the wrong color, right? Can I do what? Sorry?
Add H alpha and, because remember, like, H alpha, H beta emission is statistically what, 30%, right?
Uh-huh.
So you can add H alpha as a blue channel.
Well, I can, but I can always go back later and change the hue of the HA in this narrowband normalization script.
Change from red to more towards the purple.
Well, you could, yeah. But not, I wouldn't do it here. It would accomplish the same thing, yes. But I can make it any color I want. That's the cool part. I can do this visually. So there's an option here also to background neutralize. If your background is not a color you like, what you do is you just select an area, drag it with your mouse button, say like that, and I say, okay, apply background neutralization, and my ROI is this little spot there. I just double click, go back to normal, and it's neutralized the background automatically. You'll find that you have problems with that a lot of times depending upon the different signal strengths of your narrowband images. So anyways, if I like it, I just hit OK, create the image, and it's going to create the image. Oh, sorry, I got to save the layer, update, hit go. All right, and it has created this color image for me. There we go. So now I've got this cool color image. Maybe I want to change some things in the image. There's this nice little script called narrowband normalization, and it's in those links that I had posted earlier. I'm sorry, it's a process. Go to right there. All right. So I can now do some normalization to how the channels interact with each other. It gives you a couple options for palettes. In this case, I'm using the HOO. Gives you, I can boost the O3 in the image. I can take some out. I can adjust the shadows. I can have different cool different modes here. So if I go to like this, let me show you what it looks like. That is the that's that particular mode. It makes it sort of like the pseudo HSO type image. I can use this mode here, which makes it more like the HOO image. And then there's this mode, which is a little different pseudo HOO or HSO. So this is the typical HOO mode here. Maybe I want to change the blend of the different colors in the image. Maybe I want more red in there. Maybe I want less red. Maybe I want my oxygen 3 to be really boosted up. I can do that. There's almost an infinite number of different combinations that you can do with this. And once you like it, and this is just a normal real-time preview here, you just hit go. You're done. So, sorry. All right, so there's a typical HOO image. And of course it looks weird on this screen. It's not really as grainy as that. It's just the way the screen is. But now maybe I want to put stars back in the image. But all I took was my narrowband stars, right? That's all I have. Well, there's that SETI Astro narrowband to RGB star script, which is really cool. So if I open up my image of the stars, you know, I already made these. When I ran Star Exterminator, I just saved them. So when I ran Star Exterminator on those images, it created these two images, my HA stars and my O3 stars. And I want pretty RGB looking stars. I didn't have time to take RGB stars, but I still want them to look like RGB stars. Well, there's a formula out there that you can run through Pixel Math to do that for you, but he does it right here in a script. So you just open SETI Astro. I want a narrowband to RGB star combination. Okay, and it tells you right here, select the H alpha, O3, or optionally your S2 star images. You can also select your OSC image if a dual narrowband filter is used. So what that means is if I go back to my original image that I started with, I could just select that image. In this case, I took the stars out. I've got the stars. So my HA stars are 79. My O3 stars are 80. And I should have renamed them to something better, but, right? Apply star stretch. It's going to stretch them for me. Execute. And boom, I've got these kind of pretty stars here that look like RGB stars. Wasn't that simple? I bet some of you have tried forever trying to figure out how to do this, but it's right there in the script. It's easy. All right, so now I got my stars. So I want to put them into my image. I've got this kind of cool image over here. You know, when we could do a lot more to this, but but I want to put these stars in the image. Well, one of those scripts is called Image Blend. Remember I mentioned that? That is really a cool script. I believe it's Cosmic Photons, Image Blend. You can take two images here and blend them a bunch of different ways. You can do some of the old Photoshop techniques of blending images with soft light. I mean, it's got all the same algorithms that are available in Photoshop are here. So like here's the blend mode. I bet you all those, if you're familiar with Photoshop, you probably know what all those do. Those are all the same things, but they're available here in Pixinsight now. So in this case, I've got two images. I want to put those RGB stars into that color image. So I pick my color image, which is that one. It's going to put that up there. My blend image is going to be my stars. That's what I want to put in there. So I think it's this one. And my blend mode I want to use is, anybody know what it is? Screen. I just come down here to blend mode of screen. And there's my RGB stars, put in the image. Maybe I want to make them brighter. I can make them brighter or dark, dimmer. make them smaller. I can change the opacity of the stars. Maybe I don't want them to show through as much. Maybe I want to see more nebulosity. But for the most part, it's a pretty simple thing. You can change the black point. There's even, excuse me, there's an option here that if you can take two different images, you can run a high pass filter with one like people would do with Photoshop years ago. So anyways, it blends them right in there. You're happy with it? Hit go. And it'll create your image for you. Yeah, I think it should be there. Let's see. Oh, maybe it didn't. But it does remember, so if I bring this up again, it'll remember my settings that I used last. There it is. Okay, great. There we go. All right. There's my image. My let me zoom in a little bit. So this sort of takes out the mystery of how to. A couple of these scripts take out of a mystery of how you put narrowband images together and how you put nice RGB stars in there. I mean, yeah, it looks weird up there, but it looks much better here on the screen. Here's that little nebula here. This is a planetary nebula, a real tiny guy. That's a reflection nebula. Yeah, that's really high dynamic range screen. But it's not. It's much easier to put this stuff together nowadays than it used to be. So I use that particular way of doing things like for the last 5 years. That's all I really mess with. I just break out the stars, take my two images or my third image, put them in narrowband color mapper, pick the colors I want, take my stars if I want, and I blend them in using image blend. It's real easy. I don't need to know pixel math. Simple stuff. So, does anybody have any questions about that? Because we're coming close to, we got 30 minutes left. I got a few more things I can show you, but before you fall asleep. Has anybody used those before? Used those scripts? Okay, yeah. You apparently used a bunch of them. Yeah, they're really good. All right, let me show you this other script here, which is in my list. It's called selective color correction. So, up, wrong way. There we go. This is in this toolbox. The same guys that came up with Graxpert. You guys are probably familiar with Graxpert and the gradient correction thing, the AI thing. They have a whole bunch of other scripts, and I've got all their stuff listed on that PowerPoint. But they have a really cool one called selective color correction, and I was like, holy cow, this thing is really cool. So if I open it, it opens up my image here, and say I don't like the blue background. Maybe I want there's more HA there. I want it more red, right? Well, how do I make it more red? I could play with curves and figure out hues and things like that. Well, I can go right here to this script. Let me get it fit on the screen right for you. So I'm gonna work on the shadows. In this case, I'm going to work on the shadows, and I want the shadows. It's going to create a mask for me in the shadows. Just it's just going to do it. And maybe I want to get rid of some of the cyan. So it made my shadows a little bit redder. Maybe I want to increase the red in the shadows for sure, because it's more H alpha. You see it change? So, and you can make all kinds of different adjustments. You can change your shadows, you can change your midtones, your highlights, specific colors if you want. It offers you all kinds of different ways to change the color balance of your image if something just didn't come out right. So in this image, I put way too much O3 into the background. The O3 signal is really a lot less than what you see there. There's a lot stronger HA in the background. So I'm just boosting that up. Kind of show you what it would look like. There you go. Probably something like that. If I want to look at what the mask looks like that it's creating, I can look at the mask. I can show the mask. So this is that's what the mask looks like. It's the background mask. So that's my image. I got rid of a lot of that kind of that bluish color in the background, and I still kept the O3 here, the O3 signal here, but it's more balanced now. Now you can see this other little potential planetary nebula there. This is a really cool script. It allows you to manipulate your image in a very, very easy way. If you get kind of caught in a bind and you're like, man, how do I got to get rid of that blue? Instead of messing with curves, you just do it here visually, moving sliders. And then when you're happy with it, you're done. Hit apply. And there's my image. Now I want to put my stars back in because I fixed it. I had the wrong colors that I didn't really like. I can go to image blend. Whoops, sorry, wrong one. It's color mapper. I want script, image blend. And it'll remember my image that I had with the stars. That's much better. I like the little bit redder background there. And I can blend the stars back into this image. It'll create a new image for me. Done. So this was my new one. This was my original one here. Let me make this a little bigger. So, yep. So that's my first try at it. Two blue, that's my second try. So image blend, narrowband color mapper, using the way to make nice RGB stars out of narrowband data. It's all in these scripts, and there's only about 8 or 10 of them that I use on a routine basis. But for the most part, you have them all there. So I can't. Back up. Yeah, those are the. So these are actual links to the websites that for the folks that make these. And if you go to their website, they tell you this is what you put in your Pixinsight repository to download, and it just automatically downloads them all. Just works. So I touched on multi-scale gradient correction. It uses the observational approach. Is it easier than DBE? I don't know. We had one image, it wasn't easier than DBE. So sometimes it may be, maybe not. You may have to look at their videos. Definitely look at their YouTube channel though. Their YouTube channel has some pretty good stuff on it. These are kind of some things you may need to do to your image using multi-scale gradient correction. And that's basically right from their stuff. That's the DB extract script I talked about, which is the one that gets you the pure HA and O3 signal. And those dual narrowband filters are so popular these days. Everybody uses them. So that's why I wanted to make sure I showed you that. Narrowband color mapper, image blend. You can assign arbitrary colors to narrowband images in a nice, easy, in-your-face way of doing it without having to figure out what percentages of this or this in pixel math. Same thing with image blend. It just takes two images and blends them together. You decide how you want to do it. No more. It's got all the same Photoshop algorithms in there. Oh, there's another one here. Excuse me. The game script. This is what it looks like. The game script is a way to create oval masks and stuff. It works really well. However, SETI Astro has their own free draw mask script. So I included both of them. They're both visual ways to make masks. If you want to, you know, maybe you have an M33 in your image. It takes up a lot of the image. You want to enhance M33, but you don't want to enhance the background. You can put a mask over it and, you know, boost it up a little bit. But these are two wonderful scripts that do masks. And then narrowband normalization. It's a way to normalize the channels. There's plenty of YouTube videos out there on how to use that. Selective color correction script. I showed you how you can change like the background colors to make things more, maybe you messed it up somehow and you need to change the color, in this case from blue more to reddish. But you can work on not only the background but the midtones, and you know, it's got every option you ever want in there. And then screen stars. Well, there's a separate script for screen stars also that I included, but that's part of image blend. So, you know, image blend is the exact same thing as screen stars does, just a way to put stars back in your image. So, all right, so I figured I'd leave about 10 or 15 minutes for if anybody had any questions. Those are the ones I typically use, all that stuff, and I didn't kill myself coughing up here. Comments, questions? Nothing? Happy just to go home and try it?
Thank you for
yeah.
coming down and giving us your presentation.
Yeah. So yeah, check those things out. I know Sergio is probably going to have the video done, and you'll see all that stuff, and all that stuff will be there. So, all right. So.